Good afternoon. My name is Wiley, and today we're going to look at some these 3D design using a piece of software that I've come to like a lot, and it's a piece of software that is free, and we're going to take you through a design exercise that you could replicate at home if you've already downloaded this software. If not, you can still follow along and get to see how some of this is done. What we're going to do today for our exercise is actually make a small part that might be useful in a real situation. This is a bracket, and this bracket is just made to maybe square up a cabinet, or maybe a top on your desk is coming off, or those kinds of things. It's just a simple design, but we'd like to do it in a proper fashion. And before I do that though, we're going to look at some design software and see what is out there that you could use and why I've chosen this particular one. So let's take a look. You'll notice that there, in this article here I've written, there's a number of different pieces of software that you could use to design, and a lot of you have already probably, who are interested in 3D design, have probably used Tinkercad. And Tinkercad is a great place to start. It's created by Autodesk, and Autodesk is a great program to use for very sophisticated designs. But Tinkercad is a great one for getting started, and it's good. It can be done even on an iPad, and so on. It's all web-based, which is really cool. But if you want to move on and get into some other designs, there are some different softwares out there that you could use, and the ones that we're going to look at just by way of example today are all free in some form or another. Tinkercad is free, of course. The second one I have mentioned here is Onshape. Now, Onshape is a bit of a unique one. It's also online, and it is free for students. One unique thing about this one is that your design is visible to other people. So it wouldn't be appropriate for creating anything that you didn't want other people to share, but it would be good in an education setting. A little bit hard on a computer in terms of hardware. You might want to make sure that you've got a decent computer. Even though it's running in a browser, it will not run great on a slower machine. Probably the standard in 3D design, especially if anybody's designing for 3D printing, is Fusion 360. Fusion 360 is also made by Autodesk, and it is a fantastic program, very powerful. It is free for startups and students, anybody making less than $100,000 a year in total revenue, and it's free. If you have the paid version, there are some extra options, particularly in collaborative work, but for most of us, it would be just fine as is. The downside probably to Fusion 360 is it is a fairly steep learning curve. Once you learn it, however, it's very, very powerful. Also, there's tons and tons of resources and tutorials you can find on that program online. The one that I've chosen, this is my personal favorite for a couple of reasons. One is free, and you had to sign up for an account. With all of those other ones, you also had to have an account. This one, you have to have an account as well. One downside, maybe, it's that it's only available for Windows, but it will run on moderate hardware. It doesn't need extremely powerful hardware to run, which is also neat. My favorite thing about Design Spark Mechanical maybe is the fact that it's very easy to get started and get drawing right away, and it doesn't take a lot of learning. There are other ones I haven't mentioned here, things like OpenCAD, Google SketchUp. They're all great programs as well. And it's not to mention one at the exclusion of the other, but I think Design Spark Mechanical is a great place to get started with students after you probably left Tinkercad, or you want a little more sophisticated design. And that's what we're going to take a look at today. So hopefully you've had a chance to download the software and see if you have it installed and have created an account. So I'm going to go to Design Spark Mechanical, and we're going to take a look. So this is what we're going to draw today. We're going to do this one from scratch, and we're going to learn a little bit about the program as we go along. You can see this is what I had showed you with the camera earlier. This is our design inside of Design Spark. So let's go to our file menu, and we'll click New. And our only choice is New Empty Design. So we're going to kind of orient ourselves around the screen a little bit now, and we'll get to see how this program works. Up at the top in this area here is your main toolbar. And this is where most of the things you will be doing will be selected. You might notice over on the side there's this help feature here and so on. We generally don't spend much time in that particular one, so I'd usually just push that over as far as I can out of the way so it's not in our way. We just do it to free up our screen space a little bit. So this is our drawing area, and you can notice here our orientations. We have our X is in this direction, you can see that here as well. Y is in that direction, and our Z or Z is in that direction. You can actually change your directions, which plane you're drawing on, from here as well. And if you get lost, you can always go back to the home key to get yourself back to where you were. The view, this key here is you'll use a lot in this program because you'll be trying to move around and maybe get a little bit lost, and we'd like to have a quick way to find our way back along. So we're going to try to draw this bracket that I showed you, and I'm going to give you the measurements that we're going to use as we go along, and we're going to use a lot of keyboard entry to make this work as well. So there's a number of ways you could draw this. You could draw it with just lines. I'm actually going to start with a rectangle, and we're going to just select the rectangle, and I'm going to start at the origin. I don't have to start there, but I can. And if I drag this out, I can see that my measurements are there. Now, I can type in the number that I want right there. I could continue to drag, but I'm going to type it in, 50. That's 50 millimeters. Just like in Tinkercad, those you've used that before, the standard unit of design is typically in millimeters. So I'm going to type 50, and I'm going to hit the Tab key. The Tab key will take me to the other measurement. And I'm going to put 50 in there as well. So now I have a rectangle that is 50 millimeters by 50 millimeters. And I'm going to hit my home button again so that I'm kind of in a little closer. So now we have a place that we can start. Let's draw a line. This time, that's our first tool here. And you'll notice that when you float your mouse over, it will snap to certain points. For example, when it's on the end, it'll have this little ball shape. And if it's in the middle, it'll have that triangle shape, which is kind of nice to know when you want to find a midpoint of things. Or it will, at this point, it'll snap into every millimeter. We don't have to have it do that, but that's the way it's set up here right now. But I'm going to go straight from this corner to this corner. And I'm going to hit the escape key. And now we have a triangle that's kind of divided into two. There's a number of ways we could have done this, but I kind of wanted to introduce you to some of the other tools as well. So let's look at one of the tools that you're going to use frequently, and that's trim and delete. And there, create a corner, or this one is trim away. Trim away is a really cool one. It allows you to cut the pieces away that you don't want. Well, in my design here now, I don't want this one. So if I click on it, it'll go away. And if I don't want this one, click on it, it will go away. So now I'm down to a triangle. So I've decided that my bracket, the one I showed you earlier, is going to be 5 millimeters thick. And I think that's a decent thickness to use for a 3D printed bracket. So let's go ahead and look at another command you can use in here. We're going to look at this one here, which is a really powerful one. It's called offset or offset curve. But the offset is a really cool one because I can pick this line and say how far do I want this one away from that one, or offset from it. In this particular case, I want 5 millimeters. And I want to do the same thing on the bottom. And that's going to be 5 millimeters. So you can see now I've got lines that seem like they're all over the place, and so we can get rid of some of this now again. And this is where we're going to go back to our trim away command. So I'm going to trim away every piece that I don't need. Well, that's one. I won't be needing this. I won't be needing that one, or that one, or that one. And now we have a shape that looks something like what we saw earlier. And we're going to get ready to actually create the 3D of this, which is actually a pull feature in this particular program. Other programs might call it an extrusion. This one calls it a pull. So what we can do is, for the first time now, is we can go to the pull menu. And we're going to use this a number of times today. I'm going to pull. And now this area that we had created, it changed color and it's highlighted. And I can literally push down with my mouse and pull up. Well, I've decided that I wanted that one to be 15 millimeters high, and I'm typing in that number as I go. So now I have the basics for my bracket. So again, I'll hit the home key just to get back to where I was. So you can see now that the rectangle we started with, we kind of changed it into a triangle, and we could have done this a number of ways, as I've said, but that was one way to do it. And we kind of got those ends chamfered off, is a word we could use here, to make it look kind of interesting to look at. So if you were to take a look again back at the original design, you can see where we're going with this. And I can take the screws out of it and show you where we are. All right, let's go back to our drawing. So in our drawing now, we're going to need to put some holes in this particular one. And that's the holes for the screws. And you'll notice that the screws that I took out have a tapered, if you like, edge on them. And they're great for countersinking into wood and plastic and so on. So what I'm going to do is talk a little bit about moving around the screen for a minute now. I can rotate this by holding my mouse, and I can rotate any view I want. I can switch to pan, and I can actually pull. I can just basically pull across the screen, so I can pan back and forth. That makes it a little bit easier to move around on larger objects. I can spin, and spin will do it about whichever point we selected. And again, because we're way out of range, I'm going to pick the home key and go back. We can also zoom in on this one. We can orient it in a particular fashion if we like. For example, that will put us exactly on that fashion. So let's do that one again. So if I want to draw on here, I can say orient to this one, and it will snap around so I can see this one straight on. So in this view is where we're going to draw a circle that we're going to use as a hole in a bit. So we're going to use the circle tool for the first time. by this particular circle tool here is the one that I use most frequently. You can use some of the other ones as well, which work really well, but we're going to use this one today. When I come back into my drawing after selecting, it remembers that's the face I was on, and now I can actually draw in here. So I'm going to come in about 10 millimeters from that piece right here. I'm actually going to count them this time because they're there. And I'm going to make that hole, and I'm using my keyboard again when I dragged out. I'm going to make that hole 4 millimeters in diameter. So now I have a hole here. We don't see the rest now because we're actually drawing on that plane, but that's okay. And this hole is not a hole yet, but it will be in a minute when we actually pull this one through. And this is where this program is a bit unique compared to, say, Tinkercad. And I'm going to use the pull command. I want to show it to you in 2 ways. If I pull it out here, I create a protrusion, and I could use that. But if I pull it in the opposite direction, I create a hole. We're going to need a hole on the other side as well, so let's do the same process again just to get used to it. So I'm going to orient myself to this plane here. And I'm going to select my circle tool again. And I'm going to click this face here. And like the other time, I could do this a number of different ways, but I'm actually, and you can see that this line here is a little bit darker. I know that's every 10. So I'm going to come in, put it right 10 millimeters in from the end. And again, I want that to be 4. I could drag out for 4, or I can type the number 4 in for my diameter. And like before, we can pull it. Now I'm going to swing it around just a little bit so you can see the pull. Again, remember, if I pull it this way, it sticks out or it becomes a protrusion. Or if I pull it back, I can pocket it or pull it all the way through. So now we have our bracket that has 2 holes in it. And we click back to the home, you can get to see what we've done so far. This is great so far, but those holes won't really accept the screw well, like I had shown you in my example, and I will go back to that one again just to show you. I'd like for that screw to sit nice and flat in there. I can do that inside this program. It is not hard to do. So we're going to do that now. So let's go back to it. All right. So in here, we're going to use another command. It's also a pull command, but it's a little bit of a different one. You can pull faces, and I'm just going to show you this here now, just while I'm in this view. If I use the pull command, I can pull a face, and I'm going to Command Z to undo that. I can pull other faces, Command Z, and I can pull the edges. And if you watch this one, notice it's rounding it off. That's a really cool command as well. I don't want to do that there particularly right now, but I could make, if I pick this edge and pull it, and I'm using my mouse to pull it again, I could make that nice and smooth if I wanted to. And I could do it on the other side. And you get a nice clean edge. And I'm going to back up from them. Now you can use the undo up here. So I want to just get back to where we were, but you got the idea. All right, so let's get that hole chamfered to fit. So I'm going to go look at this particular hole here first, and I'm going to select that edge of the hole. Remember, I'm selecting the edge, not the hole itself. If you look at down at the bottom, by default, when you pull on the edge, it will round it. That's what happened earlier. Or I could use a chamfer, which is what I want to do in this particular case. So I'm going to change that to a chamfer. Now, there are some options for chamfers. We're going to look at them at another time. But I'm going to just drag this one down. I'm thinking about 3 millimeters. And there's the hole. I'm going to roll my mouse to roll back out. I'm going to swing over, and we're going to look at the next one. We do the process again. So make sure that when you're doing this one, you actually click the edge of the hole, not that. If you do this, it will change the hole itself. What we want is just that edge. So what do? We make sure we're on chamfer, and we start pulling it. Now I'm going to zoom in so you can see it a little more. I'm going to pull it, and the other one we did 3. I'm going to hit 3 on my keyboard as well. And now we have a hole that's been chamfered. So let's go back to our normal view and see what we have. So here we go. We have a bracket that's almost completed. And the only thing I think we would need any different is this is made out of, going to be printed from plastic or PLA, which is technically not plastic, I guess. And PLA is strong, but it's not as strong as other types of plastic material that you might get. So it would probably be nice if we reinforced the this bracket a little bit. And again, if you remember when I showed you, there was a piece in the center that gives it some extra support. So we're going to get ready to actually do that as well. And there's a number of ways of doing this, and we're going to do this one by using some of the commands we just used before. So we're going to build a piece on here, and we're going to pull it out, and then we're going to chamfer it off like we did with the other one. So we're going to take the orient button again, and we're going to make sure we're drawing on this plane. And then this time I'm going to pick rectangle once more. And I am going to start, I'm going to use about 6 millimeters. So there's the center line. I'm going to count 3 off this way and maybe 3 that way. So about 6. I think that'll be enough. And I'm going to come up, 6 and 20. And I use snaps in this particular case. I'll let the mouse snap to the particular one I need because I'm in kind of close. Like in the other one, I could actually type in my numbers here and then tab between them as well. There we go. And I'm going to roll this around just a little bit by holding down my middle mouse button and roll around. And I'm going to use the pull command again. And this time this is the surface we're going to pull. How far we're going to pull it out? Well, if you remember correctly, in the last one I went up 20, so it'd be nice if I also did 20 on this side, just to keep it. Well, that's pretty cool. Let's go hit the home button and see where we are. And we have now we want to probably make that a little bit more aesthetically pleasing and probably use up a little bit less plastic as well. And what we're going to do, we're going to use the pull feature again. We're going to pick that same corner. Oops, that's a face. I want the corner. There we are. And I'm going to still do the chamfer. Remember, if I do it this way, the default one, it will round it. Now that's not so bad either. But the one I really want to use is this one, which is, and actually, we're going to actually pull this one down. This one I'm going to eyeball a little bit. doesn't really matter. I'm just going to take that one, say. And there we are. So now we've pretty much created our bracket, and we can actually get this one ready to print. So just to review some of the stuff we've talked about so far. We talked about some of our creation tools. We've looked at basically 3 here. We did line, rectangle, and circle, one type. We didn't do any of the curves. We may look at them as well. We looked at one of the edit functions right here, which was basically the trim away one. We didn't look at corner just yet. We also haven't looked at move, but we've looked at pull. So we've covered some of the things you could use in a beginning drawing for this particular type of drawing, I should say. All right. Now I'm going to talk about saving files in here for a minute, because this got a little bit confusing to me first time I used the program. I found that it saves things a little bit differently, so I want to look at that in a minute. So I'm going to go File, and I'm going to click Save As, not Save. And I kind of suggest that you use that most times you use this program, and I'll show you why in a second. If I go Save As, it wants to give a name. I'm going to call this one Bracket 2 because I already have a bracket created. I'll call mine Bracket 2. Notice that the file extension for Design Spark mechanical files is rsdoc. So that's the kind of file that it creates. It's for this particular program. So if I click Save, I've now got that one saved, and I can come back later and edit. But you can save as other types as well. And I'm going to go Save As just once more and just show you that you can save them in other formats. Ones that we would be interested in particular. Notice you can even save it as a Google SketchUp to use in that program. You can save it as an image. You might want to use it in when you're doing up some lesson plans. Those teachers might do it, might want to have something like that, or to distribute to somebody else. But the one we often use, and we're going to use most often in 3D design, is STL. Those are also popular, but STL is the most popular one. And this is why I suggest that you use Save As, because another way of doing exactly the same thing is export here. Export file to various formats. It's really using the Save As command. And you'll notice that it's got some different ones. It's got Ultimaker Cura STL, which will actually put it straight to Cura. We're not going to do that one because if you don't have Cura configured exactly correctly, you might have some issues with that. We're just going to go with this one, which is Print STL. And notice it's going to call it the same name, but it's going to save this time as STL. So now I've got actually 2 files saved. I have the rs.doc file, which is the one I would use to come back and do edits, and the STL file, which is the one I would use to prepare for print. This is why you might want to keep using Save As, because if I go Save As now, it will default back to STL, the last one I did. And the problem with that is if you made some nice changes to this, you won't be able to edit them because they will not be saved in the format that you can edit again. So that's where you would go back, Save As, and make sure that you pick this type. So that gives you some chance to edit the file again later. So that's kind of a bit of a quirky thing inside the program that you might want to watch for, making sure that your design work is saved in the proper format. All right, how are we doing? Let's prep this one for printing just to see how it would look, and we could use a number of different programs. There's a lot of free programs out there. Cura, we have Slicer, SLIC3R, which is free as well, and Prusa Slicer, which uses the Prusa uses the slicer engine if you like as well. Now, just for a little bit of exposure today, we're going to expose you to Prusa Slicer as well. That is completely free and it can work on any 3D printer. So we're going to switch to Prusa Slicer just for a minute, and we're going to have a look at this. Alright, so I'm inside of Prusa Slicer. And we could do this with Cure. I'm just going to do it in here just to show you how you could use this particular program if you're interested as well. Find this program works very well. And we're now going to go get our model and put it on the bed here. So in this particular program, we're going to go Add. And notice it remember where I was from the previous time, and I called it bracket 2, so that's the file I'm going to actually bring in. So now I have my design on the bed ready to be printed, or almost ready to be printed. The neat thing about most slicers is that if you decided you need this in a little bit of a bigger format, you could scale it right in here. You could flip it over and so on. I want to talk a little bit about how we're going to print this one. The weakest part of a 3D print are the spaces, or how layers are attached to each other. So this is the best orientation to print this in, so that the printer will have continuous lines all the way around the corner. I'd recommend, we could, for example, rotate it at this orientation, but we don't want to do that. We're going to leave it where it was. But we're going to need to talk about this in right here. There's a part in here that's not sitting on a bed, but yet it might cause a problem, 3D printing. But believe it or not, those who've done some 3D printing before, this will print okay. Your printer will bridge across this enough to get it done. But if that were just freestanding, it would be an issue. But we should be able to print that one, no problem. But let's look at some of the settings inside of here so that we might want to be aware of. And those settings are similar in other slicing programs. So let's look at the first one, which will be layer height. If you're doing something in a classroom and you want to print something fairly quickly, you probably want to maximize your time so that it wouldn't take as long for student work. But if you're printing for quality, you might change it. Like layer height, for example. Layer height right now is 0.3 millimeters high. That's about as high as you would want to go. If you want to print something that's kind of a little bit more refined and smoother edges, you go 0.2, but it would take a little longer to print. The bracket I showed you today was printed at 0.2, and I'm going to leave it at 0.2 for now. Perimeters are how many times around the outside edges the printer will lay down its lines. This is a piece of material that's going to need to be reasonably strong. So it might be a good idea to maybe up the perimeters actually at least one, so that the surface is a little thicker and harder as a result. And I would do the same with the tops and the bottoms. So we've got two things done here. We changed the layer height to 0.2. We've changed the solid layers to 4 and 4. That's top and bottom. And let's move on to infill for a moment. Again, we're printing this to have some strength because it's actually going to be used to support weight. We might want to put the infill density a little higher. And I'm going to go even 30%. The fill pattern, not as important, but triangles or cubic are ones I find that work fairly well. So just to review what we've done so far. Layer height's 0.2. I usually do the same for the first layer height. And we got 4 shells all the way around. And the infill is 30%. And the pattern is cubic, but again, that one is not as important. If you're printing something, it's probably a good idea, especially if you don't know the printer that well, if you don't remember if the printer's leveled correctly or not, it might be a good idea to put a skirting in. And this time, this particular one, it's going to go around twice, and it's going to be 10 millimeters from the object, and it's only going to go 1 layer high. So you can get to see what the printer is doing, see if it's printing okay. All right, let's go back to, we'll go to support material. If I thought that piece that I had mentioned earlier was a problem printing, I could check generate support material, and what would happen then is that material would get printed underneath that piece to support it while it's printing. Now I printed this one, the one I showed you, I printed earlier, and it printed fine without supports. And because it's not as important aesthetically what it looks like, I just left it that way without having to put the material in there. All right, let's go to filament settings. So we've got our print settings basically done, the ones we need. Well, we'll look at one more, Speed. Depending on your printer, 50 or 60 millimeters a second is enough usually. I wouldn't go beyond that with most printers like the Ender 3, for example. Some other printers, Ultimaker printers and so on, could probably print at a little bit higher speed, but I would leave it normally there. So we're going to go ahead to the next tab, which is filament settings. Not much to do in here for normal. You would normally change this here. The diameter of the printer, the diameter of the filament is what you do when you set it up the first time. Extrusion multiplier is a nice one to know. If you print something and it seems like the layers are not sticking together very well, you can try putting in something like 1.1, and that will basically produce more plastic or more filament, 10% more, and you might find that may solve your problem. But most times you would leave that at 1. If you have a case where it's a lot of stringing on your print, you might even go down a lower number here. All right. That's most of what you're going to want to do in here, except for the temperatures. And this varies very much depending on what you're printing. If you don't know if it is PLA, but you're really not sure how good it is or what temperature should be done, 205 or 210 is probably a good number to start at. And you can kind of experiment from there. The print filament that I currently have in my printer here, it seems to print better lower. Some of the stuff we have at our office seems to want to print higher. We print some things at 220, and yet it seems like it's standard PLA. The bed, well, the temperature you would normally want on the bed is, if it's glass, I would suggest 65 degrees. And make sure you keep your glass extremely clean. If you're printing on the sheets that come with most printers, the flexible sheets, maybe bring it down to about 55 degrees here and here as well. But if you're printing on glass, leave it at 65. Now the print settings, you wouldn't normally need to change anything in here when you set up this program for the first time to use for your printer. It should be just fine. So let's go back to the platter. And we're going to click, this is the editor view, and this is the preview. we're going to go do this one for a minute. And we're going to zoom in really close because I wanted you to see what's happening here. You remember that I told it that it wanted to, we wanted it to go around 4 times. And if you count those here, you can see that it goes around the edges 4 times. It also does the top and bottom 4 times. And we can bring it all the way down to the bottom and see where it starts. You can see the skirt that we wanted to print first just to see how things are going. And now you can see it printing. Let's pick the other one. It's all right. You can see it printing infill after it finished printing the bottom layers. It's printing infill, the cubic version that we chose. It's starting to print. Notice it printed that out, looks like out in midair, but it will actually work. Very, very close to not working, but it does. And it will go all the way to the top until it closes in our top layers. On the lower right hand corner, you can see that how much filament is used in terms of meters, and the normal print times, it's telling me that one will take about 42 minutes to print, and that will be fairly close. So when I export my G code, and it's bracket 2 because that's the same, so it's members G code, I can now bring it to the printer, and we could basically see the printer laying it down. Well, I hope you got to enjoy some of that. Those are strange times for us right now, and there's a lot of things we can do to kind of protect ourselves and help out the community and so on. I saw this on a news article from American news site today. There's a number of versions of people printing masks or shields for hospital use and so on. This particular one is a really neat one. It was designed in Sweden, and I printed that one earlier just to print it. It actually fits really comfortably, surprisingly, and it's designed specifically for the distance between a 3-hole punch, and you use transparency material like you could buy at Staples, for example. Transparencies you would use in a photocopier to make the shield. It is incredibly light. So people are designing those kinds of pieces of software, designs in programs like Design Spark Mechanical or Fusion 360 and so on. So I encourage you to experiment, learn to design some things. This is a design also something you could use to help protect yourself. You say, what in the world is that? What it is for if you're going into buildings, you can use this to pull doors and push buttons without having to use your own finger. Maybe a good idea? Who knows? Well, I hope you got something out of that today. Please go to our site and continue to look for all the great content that the groups are producing. And we hope to see you real soon. And thanks for dropping in. Bye.